At 7:45 this morning, a mountain in eastern Indonesia exhaled with such force that the sky above it turned black for 20 kilometers in every direction. The ash did not drift. It detonated upward, 7 kilometers straight into the atmosphere above the summit of Mount Ibu, visible on satellite imagery before most of the island had finished breakfast. And within minutes, 16,000 people were being told to leave their homes, their villages, their livestock, everything, and move. This is not a story about a volcano waking up. Mount Ibu never went to sleep. What happened this morning on Halmahera Island is the latest and most violent chapter in one of the most relentlessly active volcanic sequences on Earth, and the numbers behind it should stop you cold. Because by the time the ash column hit its peak this morning, Mount Ibu had already erupted 372 times in 2026 alone. 372. That figure belongs to the official record of Indonesia's Center for Volcanology and Geological Hazard Mitigation, the PVMBG, the agency responsible for watching every tremor, every pressure spike, every sulfur reading coming from this island. And this morning they raised the alert to level 4, the highest level possible, the level that means there is no margin left. Mount Ibu sits on the northwestern coast of Halmahera Island in the North Maluku province of Indonesia, one of the most geologically intense regions on Earth. The volcano rises 1,325 meters above sea level. It is classified as a stratovolcano with a deeply nested summit crater system, an inner crater 1 kilometer wide and 400 meters deep, surrounded by a larger outer crater that has been breached on its northern side, creating a steep open valley directly facing populated lowland. That breached wall matters. It means there is no natural barrier between the crater and the communities below. This morning's eruption began at 7:45 local time. Within the first minutes, a strombolian eruption, the kind defined by rhythmic, powerful bursts of molten rock and pressurized gas, launched glowing lava approximately 300 meters above the summit rim. Ash and volcanic debris punched through the troposphere and reached 7 kilometers in altitude. That translates to 23,000 feet, the cruising altitude of many regional aircraft. The Darwin Volcanic Ash Advisory Center immediately issued an aviation warning designating it VONA-2026-IBU-01, grounding flights out of Babo Airport and triggering cancellations across the region. But the physical eruption was only the most visible part of what PVMBG scientists were watching. Beneath the mountain, seismic monitoring stations were recording approximately 150 volcanic events every hour. Not per day. Per hour. The earth beneath Mount Ibu was vibrating with relentless intensity, a signature that tells volcanologists one thing clearly. The system is under sustained pressure, and that pressure is not equalizing. It is building. PVMBG's official forecasts for the next 24 to 48 hours warn that ash columns could reach 8 kilometers, 1 kilometer higher than what detonated this morning. Further explosions are described as likely. This is not a situation that is resolving. It is one that is escalating. But that's only part of the story. To understand what Mount Ibu truly is and what makes this morning so significant beyond the spectacle of an ash column over the Pacific, you have to look at the structure of the mountain itself and what it has been doing quietly and violently for decades. Mount Ibu's first recorded eruption happened in 1911, a small summit explosion. Scientists noted it, documented it, and the mountain went largely quiet for most of the 20th century. Then, in 1998, eruptive activity resumed in earnest. A lava dome formed inside the inner crater, a slow pressurized plug of solidifying magma that gradually built up over years. That dome has been evolving ever since. Inside the crater structure, there are features that rarely get attention in breaking news coverage, but that volcanologists consider critically important. There is a large secondary cone growing to the east-northeast of the main summit. There is a smaller cone to the west-southwest, with an active lava flow tracing down the western flank. And below the northern and western flanks, there are a series of maars, craters formed by explosive steam-driven eruptions in the past that indicate this volcano system extends far deeper and wider than the summit alone suggests. Halmahera Island sits directly above one of the most complex subduction boundaries in the Indo-Pacific region, part of the Pacific Ring of Fire. The tectonic forces at work here are not subtle. As the oceanic plate pushes downward beneath the island arc, it releases enormous volumes of water-rich fluid into the overlying mantle. That water lowers the melting point of the rock, generating magma that rises toward the surface in concentrated channels. Mount Ibu sits directly above one of those channels. It is not a passive recipient of this process. It is one of its most active expression points on Earth. From December of 2023 onward, Ibu entered a prolonged eruptive phase marked by persistent ash explosions and thermal anomalies. By May and June of 2024, eruptions were generating plumes to 5 kilometers. By 2025, major eruptive events were occurring multiple times across the calendar year, and by this point, in 2026, the volcano had already recorded 372 separate eruptions, an average of more than 4 eruptions per day since January 1st. Let that settle. More than 4 eruptions, every single day, for over 2 months. The seismic record accompanying this activity shows a system that is not cycling between pressure and release in any stable pattern. It is accumulating, and PVMBG scientists have made clear in official statements that current data cannot rule out further intensification. Yet what comes next could be even worse. The secondary hazard picture surrounding today's eruption is where the risk profile becomes genuinely alarming for the communities on Halmahera's northern coast. Volcanic ash is already accumulating on rooftops and streets at depths of up to 10 centimeters in villages within 15 kilometers of the summit. That might not sound catastrophic, but 10 centimeters of volcanic ash weighs considerably more than 10 centimeters of snow. It is dense, abrasive, and when wet, it transforms into a heavy, concrete-like layer. Minor roof collapses have already been reported. 3 villages are without power. Local streams and water supplies have been contaminated by ash infiltration, creating an immediate drinking water crisis for communities that are already displaced. Those communities, the villages of Jantona, Lamatokan, Todanara, Amakaka, Buli, and Gamstal, sit within a 7-kilometer exclusion zone that PVMBG expanded this morning from an earlier boundary of 4 to 5 kilometers. That expansion tells you something critical about how scientists are reading the eruption's trajectory. When an exclusion zone grows outward, it means the hazard assessment is being revised upward in real time. Approximately 4,000 to 5,000 people have confirmed their evacuation to temporary shelters in Buli and surrounding areas. But the exclusion zone holds 16,000 residents. That means thousands of people, drawn by proximity, attachment to property, distrust of official warnings, or simply a lack of transportation, are still inside a danger boundary that volcanologists consider immediately life-threatening. The air quality within 20 kilometers of the summit has dropped to an air quality index above 200, a level classified as very unhealthy, where sensitive groups face serious health risk and even healthy adults are advised to avoid prolonged outdoor exposure. Respiratory distress, eye irritation, and contaminated water sources are not future concerns for the communities of northern Halmahera. They are happening right now. And then there is the lahar risk. Northern Halmahera is currently in its rainy season. Lahars, the fast-moving slurries of volcanic debris and water that historically kill more people than direct lava flows, require 2 things to form: loose volcanic material and rain. Mount Ibu has been depositing loose volcanic material across its flanks and the surrounding valleys for months. The rainy season provides the second ingredient. PVMBG has specifically flagged lahar formation as a heightened secondary risk, particularly in the steep-walled valley created by the breached northern wall of the outer crater. That valley acts as a natural channel, a pathway that, under the right rainfall conditions, could direct a lahar directly toward populated lowland areas with very little warning time. Satellite imagery from the Himawari 9 weather satellite is currently tracking the ash plume as it drifts west-northwest from the summit. The direction determined by high-altitude wind patterns this morning. That drift is carrying volcanic particulate across shipping lanes over communities that did not wake up within the exclusion zone and into airspace that extends far beyond the immediate island. The aviation warning from the Darwin VIF AAC remains in effect. And now, scientists fear history may be repeating itself. Indonesia is not a country unfamiliar with volcanic catastrophe. It sits on the most volcanically active stretch of land on Earth. But what makes Mount Ibu's current behavior historically resonant is the comparison to other Indonesian volcanoes that demonstrated similarly sustained eruptive sequences before producing their most destructive episodes. Mount Semeru on the island of Java in East Java province has recorded 445 eruptions in 2026 alone, making it the one volcano on Indonesian soil that rivals Ibu for sheer eruptive frequency this year. Semeru's pattern of relentless, low to moderate explosions punctuated by sudden catastrophic events is well documented. In late 2021, a Semeru eruption sent pyroclastic flows racing down its southeastern flank without immediate warning, destroying villages and killing dozens of people who believed they were outside the danger boundary. Mount Ruang in North Sulawesi, only a few hundred kilometers from Halmahera, erupted more than 6 times across 2024, with one eruption in April of that year generating a tsunami warning and forcing mass evacuations of nearby islands. Ruang's situation demonstrated a pattern that volcanologists now recognize clearly. Sustained eruptive activity does not simply plateau. It recalibrates the internal architecture of a volcano, widening conduits, shifting pressure equilibria, and creating pathways for larger events that were previously structurally impossible. Mount Ibu's inner crater, 1 kilometer wide, 400 meters deep, has been hosting exactly this kind of structural evolution since 1998. The lava dome that grew inside that crater over more than 2 decades has been subjected to repeated explosive fragmentation. Each explosion reshapes the interior geometry. Each cycle of dome growth and destruction loads the system with fresh stress. The village leader of Pululera described the human reality of this history in terms that cut through all the technical language. He described residents returning to find their water undrinkable, their crops buried, their rooftops sagging, and then described their fear that this eruption, unlike the previous ones they had survived, might not stop at this level. He was not speculating. He was relaying what the mountain had communicated to people who have lived beside it for generations, because what happens next could rewrite maps. The Indonesian National Disaster Management Agency, BNPB, declared a state of emergency for North Halmahera Regency on March 9th. Within hours, 200 military personnel from the Indonesian Armed Forces, the TNI, were deployed to assist with evacuation logistics and humanitarian operation. The Indonesian Red Cross is currently distributing masks, food, and clean water to more than 10,000 people. 50 tons of emergency supplies, tents, hygiene kits, water containers have been airlifted from Ternate, the nearest major city. 5 mobile medical clinics are operational in evacuation zone. The logistical challenge of this response cannot be overstated. Halmahera is a remote island. Infrastructure is limited. The communities closest to Mount Ibu are accessible by narrow roads that in some sections now run beneath active ashfall, moving thousands of people on those roads, particularly elderly residents, families with young children, people with mobility limitations, requires coordination and resources that are perpetually stretched in this part of Indonesia. A preliminary financial damage estimate from local government places early losses at approximately 50 billion Indonesian rupiah, roughly 3.2 million US dollars. That number will rise substantially as the full extent of crop damage, structural damage, infrastructure disruption, and economic displacement is assessed. It does not yet account for what happens if the eruption intensifies and around 20,000 people within a 20-kilometer radius of the summit remain at elevated risk from secondary hazards, ash, lahars, air quality degradation, even if they never see a lava flow. The monitoring station at Gamasi village, 9 kilometers from the volcano, is running continuous seismic surveillance. PVMBG issues daily updates, and the next bulletin is expected on March 10th. Himawari 9 satellite coverage continues tracking ash dispersion in real time. Every data stream feeding into the scientific picture right now is telling the same story. This system is not quieting. The system remains unstable. And what makes it particularly difficult to forecast is precisely the feature that makes Mount Ibu scientifically fascinating. Strombolian eruptions, by their nature, are rhythmic. They cycle. They create an almost predictable cadence of pressure buildup and release. But when that cadence begins producing events of increasing magnitude, when the baseline keeps rising, when the 372nd eruption of the year is measurably larger than the first, the cyclical pattern stops being reassuring and starts being a warning. PVMBG scientists are watching for specific signals that would indicate a transition from sustained strombolian activity to a more explosive Vulcanian or subplinian eruption style, the kind capable of producing pyroclastic density currents, the fast-moving ground-hugging flows of superheated gas and rock that represent the deadliest product a volcano can generate. Those signals include rapid changes in tremor frequency, visible deformation of the crater rim, sudden shifts in the chemistry of volcanic gases being emitted, and acceleration of seismic event rates beyond the current approximately 150 per hour. None of those threshold signals have been officially confirmed as of the time of this reporting, but the fact that PVMBG is watching for them, that these are the active questions being asked at the monitoring station 9 kilometers from an erupting summit, is itself the answer to what kind of situation this has become. There is an additional complication that sits beneath all the scientific monitoring and emergency logistics. The population of Halmahera Island exceeds 700,000 people. The communities closest to Mount Ibu represent a fraction of that number. But the logistical, agricultural, and economic disruption from sustained volcanic activity of this magnitude does not respect the drawn boundaries of evacuation zones. Ash contamination of water sources affects communities well beyond 15 kilometers. Aviation disruptions ripple through regional supply chains. Agricultural losses in ash-covered growing areas translate to food insecurity across wider networks. And Mount Ibu, the data tells us, is not done. 372 eruptions in 67 days. 150 seismic events per hour. A 7-kilometer exclusion zone expanding outward in real time. A lahar-ready landscape entering its heaviest rainfall weeks. A 400-meter deep crater with a geometry shaped by decades of repeated explosions, hosting pressure cycles that volcanologists describe only as ongoing. The mountain that erupted at 7:45 this morning on Halmahera Island is the same mountain that has erupted more than 2,000 times in the last full year. It is one of the most active volcanoes on Earth, and tonight, as ash settles on the rooftops of Jantona and Lamatokan and Todanara, and as families in temporary shelters in Buli wait for news that may not bring comfort, the seismic stations keep recording. 150 events per hour. The earth beneath Mount Ibu is not resting. It is speaking, and every instrument pointed at this mountain right now is trying to determine one thing: whether what happened this morning was the event, or whether this morning was the warning. Stay safe, stay informed, and keep watching the Earth.